Okay, here's section 3.6, page 1. We are working on the chain rule today. The chain rule finds the derivative of composite functions. All right, remembering back to pre-calc, and suppose we have f of x is x squared and g of x is 3x squared plus 7x. We want to find h of x, which is f composition g of x. So the first thing that you should do is rewrite this f composition g as nested functions. So that's f of g of x. Then start subbing in, so g of x is this 3x squared plus 7x. And we're going to put that into the f function, which will give us 3x squared plus 7x, quantity squared. Now let's square that out, and we will have 9x to the 4th plus 42x cubed plus 49x squared. There's h of x. Now let's go ahead and find that derivative. So h prime of x, just running straight product rule, or not product rule, I'm sorry, power rule here. That's 36x cubed plus 3 times 42 is 126x squared plus 2 times 49, 98x. There's the derivative. Now normally we would just stop here. But today, because I want to see a pattern, I'd like to do some algebraic manipulation on this. And one of the things that we can do is pull out a 2x. And when we factor out that 2x, we'll be left with an 18x squared plus a 63x plus 49. And then this quadratic factors, and that will factor, let's try a 3x and a 6x plus 7 plus 7. See if I check it, 18x squared, here's a 21x and a 42x. There's the 63x, and 7 times 7 is 49. And now again, because I want you to see a pattern here, I'm going to do some algebraic manipulation. Let's take this x and distribute this x back through this first parentheses. So we'll have 2 and a 3x squared plus 7x, it's all to the first power, times a 6x plus 7. And what I want you to do is to look at this line right here, where we had that 3x squared plus 7x quantity squared before we squared it out, so we have this outside exponent, and compare that to the derivative h prime. And we're trying to get from those two lines from here to here without all this junk in the middle. Do you see the pattern? We took this exponent 2 and pulled it down in front of the parentheses. That 2 came down here. Decrease that exponent on that, the 3x squared plus 7x, decrease that to a 1, left that inside alone, and then this 6x plus 7, yes, that was the derivative of this inside piece. That concept is exactly the chain rule, and this chain rule says if h of x is f of g of x, then h prime is f prime of g. We took that derivative of the outside function, left the inside alone, and then times the derivative of the insidemost function. And if we come down here now and just plug on through some examples, excuse me, this first one, let's find f prime. The outsidemost function here is this cubic, so we'll do the derivative of that cubic, which pulls the 3 down in front and changes the exponent up here to a 2, The inside stays the same. We're not doing the derivative of that 5x minus 10. We're just doing the derivative of the cubic. Now times the derivative of the inside, and the derivative of 5x minus 10 is 5. Cleaning this up a bit, let's pull this 5 around, so we'll have 15 times a 5x minus 10 quantity squared. And we see inside of here that we could factor that 5 out. Oops. That's not x minus 10. It's x minus 2. Then this 5 gets squared. So we'll have 15 times 5 squared times an x minus 2. 15 times 25 times x minus 2. And 375 times x minus 2. There's the derivative. Let's take a look at this one over here. The outsidemost function is this negative 3 power. So we'll pull that down in front when we do the derivative. F prime, that negative 3 comes down in front. X cubed minus a 3x squared plus a 1 to the negative 4th. Decrease that power by 1. Then times the derivative of the inside. And the inside piece, when we do that derivative, is 3x squared minus a 6x. Inside of here, you should see that there's a 3x common. Leaves us with an x minus 2. And then just doing a bit of rearranging here, taking this 3x, pulling it up front with that negative 3. We'll have a negative 9x times an x minus 2 times an x cubed minus 3x squared plus 1 to the negative 4th. It is acceptable to leave that derivative in this form. However, if you would like to, or if the directions say to, rewrite without negative exponents, or multiple choice doesn't have this answer, they might have something like this. And there we go. And either of those two forms are acceptable. Thank you.